next, let's introduce another bond and let's increase our wholly binomial model into two-step. Okay, so it means, okay, let me try this one. So we model this one. So this was R0, and then we had RU and RD, right? And then now let's extend the whole model again. So basically this way. So interest rate goes up again. So then becomes RU, and then interest go up and down. Then it is RUD, and then interest go down and up, but they meet each other. So it is basically same to RTU. And then interest go down and down. This is RTD. Okay. And then here, let's find interest rate over here this time. Okay, so let's delete everything here. Okay, so let's try. And then now I think we have to introduce another bond. So here, another bond. So let's say R1 is another bond. So this is interest rate for the another period. Let's say this rate is what? We can pick some arbitrary number. 30. Let's pick this number, okay? And then we have bond. Another bond is 100 face value multiplied by exp. Now we have R1 multiplied by dt, and then 3 period. 3 period is basically so 3 months, 3 months, 3 months, so it is 9 months. So A3 is basically, this is price of a bond that matures in 3 periods, so 9 months. So it is a price of the contract that pays you $100 9 months later. So let me check the price. So print A3. Okay, so price is this one. So the value of a contract that pays you $100 9 months later, the price is looks like this one. Okay, and then in order to find the path of the interest rate that is consistent with this one, so let me create another one. Now here, definition of Li2, Li2, okay, and then self M for the time being, pass, because again we need the initial value, and then sorry, and then we already have save, and then here we put another bond A3, and then self A3 equals A3. Okay, and then bond here, let's run just to check. It takes time. Okay, it takes time. Oh, okay. Change runtime type. So we can use hardware accelerator to the GPU. Okay, and then let's try it again. Then it should be faster. Oh, there is errors, which is, okay, we need A3 over here because in the class, yes, I include A3, so we need A3 over here. Now everything looks perfect. Now here, okay, let's define. So basically we can copy same one over here. Because we share this information. And then we need, oops, we need new M0. Let's say this is MO. MO is should be self, and then here, this one, M0, M0 over M, right? Because we want to reuse, we want to reuse the previous, we want to reuse the previous one, previous M. So at the first step, we already know the M part, the drift part, and we can only find the second part of the drift term. And then now we can simply call this one. Let's call this one. Okay. RURD. You can call this one again. And here, this is MO because you already know this one. And then now RDD is from RD. We go down again, right? We go down again. So go down again. But first we need drift, of course. M multiplied by dt. And then minus 4 dt. And to the power of 0.5. Okay. Because it goes down. And then RDU goes up. It becomes RDD plus 2 times of this one, right? Same. And then RUU equals RDU, again, plus 2 times of this one, right? It is basically the same principle of this one. So because here, right, it should be goes up 2 times. So 0 and plus this one. And then here we goes another, cancel out this one. So we have to add 2. So we always have to add 2 times, right? And then we calculate this one. So now we have to calculate bond price. Now we have a 3 bond price. So N1 equals, again, face value 100 multiplied by the R1 is here. Okay, we goes up. So let's use up probability of interest rate. So RUU multiplied by DT, right? The final period. And then N2 equals RUD, RTU, and then N3 equals 100 RDD, right? And then now from this one, we can calculate the price of they are the price of the 9 months bonds after 6 months. So we have 3 possibility because we have 3 interest rate. Now we have step 1, 3 months back, 1 period back, and then answer 1 equals 50-50%. So N1, N1 plus N2, right? N1 plus N2. And then we have interest rate over there. So multiplied by EXP minus RU multiplied by DT. Okay. And then answer 2 is RD. Our final theoretical bond price is, of course, again, it is 2, 0.5 multiplied by now answer 1 plus answer 2, and then because now it is 3 months, so it is R0 multiplied by dt. Okay, and then of course now we can return the gap between N0 minus self A3, right? And then now, of course, we can solve for this one. And then let's try. Now M2 equals F solve bond 1 and then Li 2, and then let's pick initial value 0.01 and then pick this first one, okay? And then print. Okay, so apparently we found the answer. Okay, so if we pick this one and then to check the answer, bond 1, Li 2, M2, then we have a pricing error. This is practically 0. So we have found correct one. So let's include this one into our code as well. So definition, define function. Now it is M1, and then self M, and then we can do fsolve, return, fsolve, and then self Li 2, right? Self Li 2. And then we can put the some initial guess, which is M, and then we can pick just the first argument. Okay, and then let's try print bond1 m1 equals, okay, initial guess, and then we have the same, slightly different. Let's reduce initial value. So we have the same value. So our calibrated value. So let's delete those things. Too many prints. So M1, M2, bond 1, bond 2, M. Okay. Let's delete everything over here. And then print calibrated terms. So print first period M is basically bond 1. I forgot name, bond 1, and then M0. Okay. Bond 1 and M0, and then M, initial value, and then print second period M, which is M1, and then execute it. So, right, we have first period M and second period M. So now we can successfully calibrate the interest rate. Okay, so to show the interest rate tree, what we can do is basically, now we have interest rate tree for the 2 period, and then I want to show you how the interest rate tree evolves, and then so let me think about it, how to do that. So what we can do is here. So first line is okay. So we have R0 and R1. So of course we have R0 and RU equals R0 plus, okay, so bond 1 M0 over M multiplied by dt, right? And then we have a minus volatility, and then dt to the power of 0.5. So basically same to this one. So I just want to show you the path of the interest rate, and then RD is RU plus 2 times of this one. Okay. And then RDD equals RD Oh, sorry, here it should be R0. RT, again minus, first plus bond 1. Now M1, M multiplied by dt, and then going down again. So this one. And then RDU equal RDD plus 2 times of this one. And then RUU is RDU, oh, this one. Okay. And then using this one, I can show you the interest rate data. Interest rate data. Okay. Short rate, because it is the short rate, 3-month rate. Short rate data equals first, it is the it is from the top, it is the top, it is the 0, and then 0, and then RUU. Okay. And then middle first one is 0, and the second one is RU. Okay. And then third one RDU going up. And then bottom is R0, first one R0, and then RT and another RTD. Okay. So basically this is interest rate data. And then let's print. If we print short rate data, looks like this one, looks like this, and this is not so pretty. So let's make it prettier. So instead of this one, we can call from, okay, from tabulate, import tabulate, okay. And then, oh, I think I made a mistake, but let me continue. Sorry. It is the, well, I'll show you what's wrong, but let me continue. Print, tabulate, and then we want to tabulate the short rate data, and then headers, keys, and then table format, pretty, looks like this, and then, yes, this is, sorry, this does not make sense. This does not make sense. So this is the step 0, step 1, okay, step 2, okay. And then step 1, this should be, in fact, R0. And then this should be the RT, and this is RTD. And then this is RD, RU, RT. U and R UU. Okay. Okay, now this looks much better. Okay, so initial interest either go up or go down this amount, and then again go up or go up or down and up, and go down and down. So this is the path of the interest rate. Okay, that's it. Pretty. Okay, this is actually looks better. Defaulted looks better. So here, print calibrated path of interest rate. Okay, so this is calibrated path of interest rate. So initial and then going up or going up again, and stay going up, and initial go up and go down, and initial go down and go down.